In this video, I'll show you how to solve the ALEKS problem called writing the electron configuration of a neutral atom with S and P electrons only. In this problem, I'm being asked to write the electron configuration of boron. Let's go find that on the periodic table. It is right here. And I'm going to use the periodic table to help me write the electron configuration. On the periodic table, the row number is the same as the principal quantum number, like n equals 1, n equals 2, n equals 3, and so on. These two columns on the periodic table are filling up s orbitals, and these 6 columns over here are filling up the p orbitals, with exception of helium, which is still filling an s orbital. So if we want to use the periodic table to count an electron configuration, I'm going to redraw that. What we need to do is, no matter what element we're working with, we want to start with hydrogen, and then we just want to work our way across the periodic table until we get to our desired element. And we're going to count electrons as we go from hydrogen to our desired element, using these sort of guides that I've written here for you. So for example, hydrogen, this corresponds to n equals 1, and it's in the s. So this, the electron in hydrogen is in the 1s orbital. And next is helium, and this is still in n equals 1, and it's still in the s. So this would be the second 1s electron. So that means that there are a total of 2 electrons in the 1s orbital. We'll write that over here. And now we move down to the next row and we do the same thing. So lithium, which is the third element, this corresponds to n equals 2, and it's in the s orbital. So this is our first 2s electron. And then we have beryllium. This is also in n equals 2. It's still in the s orbital. So both of these represent 2s electrons, and there are 2 of them. So that's 2s2. And then we continue across. Now we're at boron. This is our target element. This is still in the n equals 2, and now it is in the p orbital. So this is 2p. Boron is the first in the 2p, so this is 2p1.